How do robust clustering algorithms help Sora to improve the quality of images and videos that is given to us? Today we're gonna talk about it. How are you doing, whole universe? Hope to this fine. I'm a Rashman who being followed through my own experience. And let's dive into the text-to-video generated content. OpenAI yesterday published new papers on new technologies that is generating videos to us. For example, we can say, hey dude, hey GPT type of thing, let's do the video of the girl walking on Tokyo. Okay, she is walking a nice quality. Previously, 1 year ago, we all laughed at Will Smith that is eating spaghetti, mom spaghetti, his no response, surface skull already. Okay, the Eminem lyrics. And right now we have the girl that is walking on Tokyo. Wow, it's interesting in Tokyo. And also, right now we have the new footages of some lighthouses and also seas and different types of waves and wow, quality content. And also we have some of the birthday things that are appearing here. And actually we have high quality content right now from the video generation in terms of the GPT. You know what is GPT, you maybe used it already. If not, then you are living right now in the era of dinosaurs or something like this. Okay, our talk today about robust clustering and things of this nature in terms of the Sora. Sora, again, Sora is the text to video generation content model and things of this nature. Okay, it is the tool that we write, for example, let's generate some Rubik's Cube, and here it has appeared something, but not super quality, but nice in terms of the, if you will look at the stock photos, then it will look the same way, stock videos I mean. Kind of. Okay, and robust clustering. What is clustering? Clustering, it is when we collect all the data. I imagine that we have x-axis and y-axis, and also we have dots inside of it. Wow, interesting. And also we have some groups, the sets, subsets, multi-sets, supersets, and things of this nature that is connected to each other. Here's one set, here's another set, here's the third set, and etc. What is robust clustering? Robust clustering, it is sub-area of clustering, subdivisions, sub things, subfield of clustering. Okay. Imagine again we have dots. Imagine that we have here dots, here dots, here dots, and also we have some points that is here, exaggerated points, 2 points that we don't need, actually outliers or anomalies, or out of distribution data. And we have here the main clusters that we'll look at. And if we will calculate some aggregation functions from these three things, for example, mean number, a number, arithmetic mean, then our centers of clusters could be a little bit switched from the center, real center, yes? And it will be kind of disturbing, kind of not really useful to use this aggregation functions when we have these two outliers that are kind of corrupting, interrupting, and things of this nature, kind of destroying our thing in some percentage, okay? And we need to delete it, and it will be robust clustering. Delete or eliminate or remove or maybe decrease the influence of this thing, and then we will have it. Okay, imagine again, we have x-axis, y-axis. I will give you right now the better example. Imagine that we have only one cluster, yes? Here's the dots. Yes, dots, a lot of dots, and here's a kind of exaggerated points that are appeared here that we don't need actually. It is not the cluster, it is some of the noises and things that are disturbing the main points that we have here. I imagine that we don't have it first, we have only here dots. The center of cluster will be here. If we will appear outliers here, then the center of clusters, if we will do some mathematics of arithmetics and we will calculate arithmetic mean, then we will have it here, kind of, yes, if we will have dots here. So the center will be switched. What does it mean to us if in terms of the Sora? In terms of the Sora, it means that some of the colors, we will not have the kind of orange color, we will have kind of this color, yes? Imagine, look at this. Actually, is it the same color of orange or not? It is different. Yes, look at this. they are different. Yes, they are almost the same, but they are different. Kind of, this is more kind of lightly orange. This is another. And I imagine right now that you have the picture right now. Yes, I made. You can look at the screen, and I imagine that here is some of the dots, some of the pixels, and maybe on the borders, on the edges of the objects, and these types of things, they are kind of changing the color from this to this. And it is kind of interesting thing going right now. And it means that our quality of image will be not really nice. Maybe we will look at the picture and it will be not super realistic as it could be. So robust clustering helps us to improve the quality of color. It is the first thing that it helps to us to do. Next thing, it is the position on the points. I imagine that we have kind of the position of the person who is walking. We have biomechanics of this person who is walking, and on the image we have the walking of the person. Okay, everything is fine, she or he walks and everything is fine, but because of outliers, because of the data that is super exaggerated in the higher position on the or the super low, I mentioned that here is the origin of the points. Yes, we have x-axis, y-axis, and here is the 0, yes, for example, or minus here is somewhere, and here is the exaggerated plus positions, it is exaggerated minus position, and here is the switch. I mentioned that we have the person who is walking, yes, walking, race walking or something like this, and then we have the switch of his movements of the legs a little bit non-natural. We will have that he is walking not really nice. That I imagine that you play the game and some of the arm goes to this side, not like this if he is eating something, yes, but who eats with hands, but okay, but I imagine that but in terms of the not sweetest or kindest, in terms of the normal food, yes, and I imagine that you have kind of this type of thing, and if you don't have robust clustering, your movements will be kind of inside the textures, begging, yes, begging in terms of begging, it is another thing, bag, yes, it's here, but it is bugging, yes, or lagging, or something kind of intersecting the area of the main pixels. Right now you understand me, okay? And it's fine. And it's about robust clustering in terms of the movements that we have. Yes. Okay. We have right now we have to talk about the pixels, also about the movements, about biomechanics of the person or the not person, or maybe of the dogs or something like this. And also we have a robust clustering in terms of the text, because it is text to video service, text to video model, large language model, or something multi-model large language model. Actually, you can name it anywhere, anyhow, but actually it is generative model that generates something from the input, and we have output. Okay, everything is fine. And I imagine that we have right now the text that you typed, and some of the changes. Sometimes when you type, you need to there are different steps inside of the prompt that is going to do. For example, you wrote need to do this, and this should be kind of averaged, and also again calculated as the mean number, or maybe kind of doing the centroids, midoids, and need to connect to make it kind of shorter, then much shorter and more precisely. And when we talk about preciseness, I imagine that you have preciseness of 96% or 97.7%. Actually, 96% it is less than 97.7, and actually it will be more precisely in your wanting, what you want to see on the picture. It means that, I imagine that you said that you need to see something for example, shaker, you need to see kind of green, but for example, you wrote that you need to see dark green shaker, but actually it's given to you light green shaker. I'm imagine it, yes, but you said green, you said black green, but it given to you this type of things, okay, and it is kind of exaggerated examples. I understand that 96% and 97.7, it is another thing actually, because it is kind of, if we will imagine in terms of the RGBA, yes, and we have 255, I imagine that the green value will be, it is actually a white color if we talk about RGB, 255, and 255, and I imagine that you have the value of your green value, value of the green value, we have the green value of not, for example, 180, but 172, or maybe 173, or maybe not 180, but 184 or 83. Actually, yes, it is almost the same, but not fully. And the same with your text, textual information. For example, you have a lot of words, a lot of synonyms to describe the thing, and you have, for example, to say about the water container in terms of the natural water container, sea or ocean or river, and river, ocean, lake, and also you have different types of water containers, natural water containers, and you said that you have, for example, yes, lake, sea, river, and maybe pond, yes, and you have this type of things, 4 things, and what to choose, what will be more precisely, is the river the same to the lake? Not actually, and the same thing with it. For example, you wrote you need to see the lake, but it showed to you the river, and actually river, and it is kind of the different things. And robust clustering helps to you to kind of to be more precise in this type of things. Actually, yes, it is exaggerated because river and lake, it is kind of not the same, and actually it is not the one value of percent or maybe 2 values of percent. Actually it is bigger, it is maybe 20% difference between them. I imagine that in terms of the numbers, for example, lake it is 20 and river it is 40, yes, for example, yes, and it is kind of different types of values. It is not 20 and 21.7, and actually it is bigger, and I imagine that you have some of the speech, and speech is written in terms of the numbers, and the words that you describe, they are almost the same to the words that are standing right now on the position that is almost similar, 1.5% similar to this. And actually it is different things, and you will have this type of image because you wrote this, and robust clustering was not given to us. And okay, it is our things of our our talk that we given today, and that I produced to you. Actually, it is interesting. You can go to the OpenAI Sora to check it by yourself. Actually, it is not the promotion, because I noticed that, wow, Jesus Christ, new things appeared here, and it's kind of quality. And you can look at this by your own, and let me know in the comment section below, did you understand me? Because I publish it on Chinese platform too, and Chinese people, they are learning English too, and actually it is interesting to communicate with you. And thanks a lot for you, China, and thank you a lot for Russian people who are watching it too, and to other people around the world, Indian, Indonesian, and Malaysian, and others. See you next time. Professor Daily, go forward. Everything depends only on you, and be cool. Improve Daily again, and go forward. Improve your models. Do robust clustering. Improve your models. Improve your algorithms, and everything will be fine in your life. So thank you a lot, machine learning engineers. You're the best machine learning engineer, and improve Daily, go forward. Everything depends only on you in your life. See ya. Bye bye.